Okay, let's solve some different types of equations. Number 13. A is an absolute value equation. And for this, you have to remember the three important steps. One was to isolate the absolute value. So we'll do that by subtracting 5 from both sides. We have the absolute value of x minus 4 is equal to 7. The second step was to break out of jail. Remembering that absolute value means the distance something is from 0 on a number line. So the expression x minus 4 has an absolute value of 7, which means that the actual value of x minus 4 could either be 7 or it could be negative 7. And then we solve both equations. So we get that x could either be 11 or x could be negative 3. Okay, B is a quadratic equation. X squared plus 9x plus 18 that we learn to solve by factoring. So the first step here is to factor. And remember that we're looking for two numbers that add to 9 and multiply to 18 when we factor. Those two numbers are 6 and 3. So this trinomial factors into the binomials x plus 6, x plus 3 equals 0. And now remember the zero product property. Says that if A times B equals 0, then one of these two things must be 0. So either x plus 6 equals 0 or x plus 3 equals 0, which makes x either negative 6 or negative 3. Letter C is another quadratic equation in a different form this time. We didn't see too many like this. But this is a situation where you can factor out a greatest common factor, but it's not going to help you very much. Okay, this situation is actually easier if we bring this 36 over here, meaning that there is no x term, it's just an x squared term. We're going to solve it like a regular equation. We'll add 36 to both sides. We'll get that 3x squared equals 36. And then we're just going to treat this x squared as if it was just a plain old x. We're going to divide both sides by 3. And we'll get that x squared equals 12. Okay, so we know that x squared equals 12, but we want to know what x equals. So this means that something times itself has to equal 12. And there's nothing pretty. It's not like something times itself equals 16, where we could easily say what the answer would be. This is a situation where we just take the square root of both sides, and because we're not really sure what it is, and we get that x equals whatever the square root of 12 is, which looks like, let's see, is 3.464 approximately. Okay, but keep in mind that when we take the square root of a positive number, there's actually two possibilities, because 3.464 times itself could give us 12, but negative 3.464 could also give us 12. It might be easier to consider this type of problem in an example that we're a little more familiar with. So this is just a separate example. It's like a bonus here. What if I had something like this? 4x squared equals 64. And we divided both sides by 4 to get that x squared equals 16. So here we're pretty familiar. If x squared is 16, we can come up with a number. When we multiply it by itself, we get 16. Okay, but same thing, we're really taking the square root of both sides. So x could be 4, but again, keeping in mind that not only is 4 times 4 16, but negative 4 times negative 4 is also 16. So over here was just an easier example with a square root that you're more familiar with, rather than having to take the square root and give an approximation. Okay, one last one here, part D. Quantity x minus 5 times 3x minus 2 equals 0. So this is an equation that's already in factored form. So resist the urge to multiply, because you're going to make your life a lot harder. It's already factored. We can go right to the zero product property. That again says if something times another thing, A times B equals 0, then one of these two factors must equal 0. So either x minus 5 equals 0, or 3x minus 2 equals 0. This would make x equal to 5, or 3x equals 2, so x equals 2/3. So here are our two answers.